Hey guys, so I hope you guys are all doing well. Hold on a minute, I'm having a little technical difficulty. Okay, so before we get started with today's lessons, I want you guys to remember if any of this information is confusing or if you have any questions, you can email me directly. So you don't have to wait till mom and dad are home to ask them to message me. So go ahead and just use your Google account to email me yourself. Okay, just remember to only email me between the hours of 10 to 3 o'clock and only on Monday through Friday. Okay, so let's get to it. So in our last lesson, when we looked at adding fractions where the sum is greater than 1 or 1 whole. So for example, if you look at on your screen right here, if we wanted to add 7/8 plus 7/8, we know that we're going to get a sum greater than whole, right? Because this one is almost a whole, and so is this one. If we add them together, we're going to get something much more than whole. So if we look at this model, we can see that. Okay, what we're trying to do when we add two fractions is we're trying to make another whole. And we do this by taking fractional pieces from one of the add-ins and getting to the other add-in so we can make, again, one whole. As you see here, from this one, we're going to take 1/8 piece and we're going to put it up here to make this one whole. So you would have one whole and then you would have 6/8 left, which you can see this is the mixed number. It would equal 1 and 6/8. We can show this on a number line as well. So the numbers on here are really small. I apologize for that. It's kind of the best I can do. But if you notice the number line, it's going to be divided into fifths because our denominator is fifths. And so these are going to be divided into fifths. So here we're adding 4/5 plus 3/5. We know the sum of these fractions it's going to be more than one whole, but how much more? Well, we start off at having 4/5, and then we add 1/5, 2/5, 3 more fifths, and what we land on is 1 and 2/5. Okay, what we're going to learn today, though, is how to add mixed numbers. So in the problem you see here, we're going to add 1/2 and 1/2, 1 and a half plus 1 and a half. Now this problem is probably pretty easy for you guys to solve mentally because we can see right here we have one whole and another whole. That would be two wholes, right? And if you add the two halves together, that's going to be another whole. We're going to look at this using a model load so it can help us when we get to a more difficult problem. We're going to be using pattern blocks to model this. Now, when you get it into yourself, when you start drawing models, you can use rectangles or circles, but for today's lesson, we're actually going to be using pattern blocks. Before we begin, we have to have a reference for what one whole would be. So one of these yellow hexagons will equal one whole. All right, and the red trapezoid, one of them is going to represent a half. So 2 halves is the same as one whole. Now, if you look down here, one of these blue rhombuses will equal 1/3 because it takes 3 of these to cover one whole. So 3/3 is the same as one whole. All right, and then down here, a green triangle will represent 1/6, right? Because it takes 6 of these green triangles to cover one of these. Let me hide this little thing down here. Okay, so 6/6 is the same as one whole. All right, we're going to look at this number. Before we get to adding mixed numbers, I want you to see this with adding 2/6 plus 3/6. Again, we're using the green triangles because look at our denominator. We're talking about sixths, right? So we know that one green triangle is 1/6. So 2/6 plus 3/6, and over here, that would equal 5/6. Now, if we put all of these together, as you see down here, this is what it would look like. It doesn't quite make a whole, right? We need one more 1/6 piece to do that. So now let's move back to this problem. 1 and 1/2 plus 1 and 1/2. We're going to model this with pattern blocks. So since our denominator right here is 2, that means that we're going to be adding halves. And halves are represented by the red trapezoids. What we want to do is add pieces together to make another whole. So we can do that by adding this piece here, and taking over here and adding it to this one. And what we'll get is 3 wholes. Okay, let's try another. So here we have the problem 1, 5, 6 plus 1 and 5, 6. So before we get to showing this visually, I want you to think about what the answer might be. So take a minute and pause the video if you need to see if you can figure out what the answer will be. But remember, what we're trying to take pieces from one fraction and give it to another to make a whole. Okay, so let's see if you guessed correctly. Since we're adding 6, right, because the 6 is the denominator, we're going to be using green triangles. Okay, so if we look at the problem visually, we can easily see that if we move this 1/6 piece over here, we can fill this up and make another whole. And what we will have when we put that together is something that looks like this down here. We're going to be having 1, 2, 3 wholes and 4, 6. Okay, this is showing how it will represent an improper fraction. That means we have 22 of these green triangles, but the mixed number would be 1, 2, 3, and 4, 6. All right, so we're going to try one more before we end. So I'm going to give you the problem, and I want you to see if you can figure it out on your own. If you need to use a drawing at home, go for it. And then I'm going to switch screens, and I'm going to show you using pieces, moving pieces, so you can see that. So here, just bear with me. Let's switch over here. So here is this problem represented visually. So here we have 2 and 3, 6, and to that we're going to be adding 1 and 4, 6. Again, we want to try to move these pieces together so we can make another whole. Well, down here it's 4, 6, so it's closer to being a whole than this one. So I'm going to take pieces from here, and I'm going to move them down here. So I have one more I can go. So I'm going to move this 1/6 piece. Bear with me. Come on. Okay, there we go. So now if we look at this, how we're going to see how many holes we have now. Well, we have 1, 2, 3, 4 holes and 1/6. So our answer to our previous problem is going to be 4 and 1/6. That would be the answer.